During this lesson you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Foundations Part 1, Below Ground. Learning outcomes. By the end of this lesson you should be able to 1. Describe what a foundation is. 2. List the 5 steps for setting out a foundation. 3. Explain what effect the bearing capacity of the ground has on the choice of foundation. 4. State the minimum depth of state the minimum depth a foundation should be below ground level. 5. State the minimum thickness of a foundation and its minimum projection beyond the face of the wall. Artificial and natural foundations. The building's foundation or concrete structure is sometimes referred to as the artificial foundation and the ground on which it sits as the natural foundation. You can see in the diagram in the bottom right hand corner is an example of an old type of foundation. This is the type of foundation they used to use before they had concrete. And we can see the rising wall. This is a section through a trench, so we can see the rising wall that would be coming up from the top of the foundation up above the ground, and then underneath that, then as part of the foundation, we have what's referred to as spreader courses. These would be spreader courses of bricks were built directly onto the natural foundation, so they dig down quite deep until they hit good solid ground, and then they'd start the wall really wide, about 3 times the width of the actual finished wall up above so about 3 times the width of the wall, and then they just slowly step it in as they were coming up until they came up out of the ground. Spreader courses. Like I said, sometimes years ago they used to call the ground the natural foundation. Foundation definition. So these days the foundation is the part of the building in direct contact with the ground. So this is going to be the concrete that we use these days for foundations. The foundation's function is to transmit all loads from the building to the ground. These would be dead loads. They're the loads of the actual building itself, the walls, the floor, the roofs. The imposed loads, which would be internal walls, furniture, equipment, plant and machinery, whatever's going into the building itself, and then also wind loads. So as wind is blown against the side of the building, the force from the wind is transferred into the walls and down into the foundation. So this is detailed in Technical Guidance Documents Part A, page 3. So we can see an example in the image there in the bottom right hand corner of the slide of the foundations of the concrete foundations. Foundation definition continued. In practice, the concrete base of the building is described as the foundation, and the part of the building below the ground and the horizontal DPC or damp-proof course is described as the foundation wall or the rising walls. So we saw on the previous slide, a trench is excavated, then the concrete is poured in there. That's the concrete foundation. But also included in that then are the foundation walls. Like I said, these are called the rising walls, and we can see an image in the image on the bottom right hand corner there, an example of this. The rising walls are the walls that are built underneath the ground level, and they're built up to the damp-proof course level, and we can see an example of somebody putting down a damp-proof course there in the image in the bottom left hand corner. The damp-proof course is used in order to prevent moisture rising up from the ground into the building. Functional requirements for foundations. Strength and stability, which is covered in Part A, Structure of the Technical Guidance Documents, covers this. The foundation should be designed so that any settlement is both limited and uniform under the whole of the building. So we want a limited amount of settlement after a building is constructed. There's going to be a certain amount of settlement, certain amount of kind of movement as all the loads are placed on top of the foundation and the building is constructed. There's going to be a certain amount of settlement and movement, but the idea is when we're designing the foundation that we want that settlement to be limited, so as little as possible settlement, amount of settlement, and then also we want it to be uniform, more importantly. So if the building is settling, we want the whole building to settle at the exact same rate and the exact same amount. In other words, we don't want one section of the building settling more than the other. Then we're going to get cracks in the building. As the building is erected, the loads placed on the foundation increase and the soil is compressed. So it's important that we dig down until we get to good solid ground. Functional requirements continued. The bearing capacity for the rocks and soils below the foundation are assumed, and these should not be exceeded in the design of the foundation. So we dig down. There's a number of ways to know how far we have to dig down until we can hit solid ground. Well, obviously if you're digging down and the ground is getting extremely hard, that's one way, but there's lots of other surveys we can do in order to estimate the required depth, and we'll have a look at them now in a few minutes. So worksheet question 1, describe what a foundation is. So setting out the foundation, 5 steps to setting out the foundation. Number 1, timber profiles are set up beyond the edge of the trench in order to support the lines. We can see an example of this in the top right hand corner of the slide there. So these timber profiles are set up in order to support the lines, and they have to be set up beyond the edge of the trench. If we're excavating by hand, you maybe want these to be about a metre beyond. If you're going to be excavating using a digger or a machine, they might need to be further back from the edge of the trench to allow the machine to get in and access the trench. Number 2, the outline of the foundation trench is marked out square. So all our angles are set out nice and square, or if there are other angles that are required to be set out, they have to be set out correctly. Number 3, the trench then is excavated by hand or using a digger. The sides and base of the trench must be plumb, that's perfectly vertical, and the bottom of them have to be perfectly level, and the corners have to be square. This is in order to ensure that when the concrete goes in, the concrete will be the same depth all the way around, because we're going to have to put the concrete foundation in level. So if we don't have the bottom of the trench in level, then when we put our concrete in level, we're going to have different depths of concrete around the trench. So that's why it's important when we're digging out the foundation, the bottom is perfectly level, the sides are perfectly plumb or vertical, and the corners are square. Setting out foundation continued. Number 4 then, the trench is then pegged out using steel bars or timber stakes. We can see an example of this in the image on the right hand side. Steel bars are tapped down, the top of them are leveled using a spirit level and a straight edge, or maybe a laser level, and they have to be evenly spaced out, and of course the peg is going to be driven down to the required depth of the concrete for the foundation. Standard depth is going to be about 300 mil for a standard concrete foundation. So these are driven into the bottom of the trench and are leveled on top. They are used as a guide for the depth of the concrete and also to level off the concrete when it's being poured. Setting out the foundation continued. Step 5, the last step. So a timber screed spans from peg to peg and is used for leveling the poured concrete. So how we do this is the concrete is poured in. We can see the image in the bottom right hand corner there showing the concrete being poured into the trench, and then what would happen is 2 operatives or 2 craftspeople would have the screeder board, which is a big heavy length of timber, and they would use the pegs as a guide in order to make sure that the concrete is level. And also sometimes, depending on the depth of the trench, what we'd have is, we can see in the top right hand corner there on the slide there, we have an image there of the screeder board, we have the two steel pins, red steel pins. They're indicated there by two red lines. The steel pins sticking up out of the bottom of the trench, and quite often we'd have timber handles fixed to either end of the screeder board, and we fix these by just hammering one nail through the handle and straight through the screeder board. Only one nail, because this allows the handles to move. So when we start tamping the concrete up and down in order to get it level and screeding it back and forth, making sure that we're going by our pegs. So foundations and rising walls. Rising walls are a part of the foundation as well, which, as I mentioned earlier on. So after we have our concrete foundation in level, we build up our rising walls. So the rising walls are built up always using solid blocks, not cavity blocks, which is the image in the bottom right hand corner there. It's a cavity block. We never use them for our rising walls. They have to be solid walls. In this particular example here, we're using blocks on flat, because the wall is going to be 215 millimeters wide. That's the thickness of one block on flat. So they're built up, so they're perfect level, and they're usually built up to a damp proof course level. Okay, worksheet question 2. List the 5 steps for setting out a foundation. Bearing capacity of the ground. This is expressed as newtons, or newtons per millimeter squared. So it's resistance. It's the ground's resistance to a force. It ranges from 10,000 newton for solid rock down to 75 newton for cohesive soils. Peat and organic soils are made up ground and fill are not suitable for building on at all. A variety of site investigations can be used to help determine the ground formation. Types of soil. Topsoil. The surface of most land is covered with a layer of soil or vegetable soil to a depth of about 100 to 300 millimeters. So it is loosely compacted, supports growing plant life, and is unsatisfactory as a foundation because of its poor bearing capacity. It should be stripped from the site and retained for landscaping around the site. So the first thing we do is we strip off, wherever the building is going, the top 300 mil of soil, of topsoil. Types of soil continued. Subsoil then below the topsoil. The majority of subsoils are mixes of various soils. So gravel, sand and clay may be combined in a variety of proportions. The nature and behaviour of these types of subsoil under a load on foundations are quite similar. So there's no differential settlement, and that's important. The real problems arise when proportions are uneven. So if there's an even mix of different types of materials in the soil, like I said, like gravel and sand and clay all mixed in, that's grand. But when we have excessive amounts of rock or peat are present in different sections, under different sections of where the building's going to be constructed, or the wall or whatever is going to be constructed, then we can have a problem, because we could have differential settlement, like I was talking about earlier on, where it could settle more in one spot than in another spot, and that's how we end up getting cracks then in the building or in the structure that we're constructing up above this ground. So site investigations. These are carried out in order to ascertain, 1, the nature of a subsoil. So what type of soil is there? 2, its bearing capacity. 3, its likely behaviour under seasonal and groundwater level changes. So in other words, if we start excavating down and we see that the water table is quite high, this could be an issue. 4, the possibility of ground movement. That's why we need to ascertain what type of subsoil it is. And 5, the type and size of foundation required. So an investigation continued. Methods used. Here's a number of methods that can be used. We can carry out geological surveys, or if you don't want to carry out a geological survey yourself, you can go to the local authorities, and they'd probably have records of any geological surveys that would be carried out in the local area. we can simply look at adjacent buildings to do a bit of a work survey or an inspection. So if there's a building close to the vicinity where you're going to be constructing, or another wall, or you're going to be extending onto an existing building, we can simply excavate down beside this building or the structure that you're going to be building beside and see what depth their foundation is. And if their building is standing up fine, then just go with the same depth foundation as theirs. We can use trial pits. These are excavations on site. These are for larger sites maybe, or if you're not too sure about what kind of subsoil we have. We can use borings also. This would be maybe, if we're on ground that's going to have to be piled. In other words, we're going to have to send foundations down quite deep. So these are borehole samples on site. Okay, worksheet question 3. Explain what effect the bearing capacity of the ground has on the choice of foundation. Ground movement. Foundations for dwellings should be a minimum of 0.9 meters below ground level in order to avoid movement due to 1. Frost heave. This is expansion of the ground. So the maximum frost penetration into the ground will be 0.5 up to 1 meter below ground level. In order for it to go down to 1 meter, it would have to be extremely cold and in a very exposed area. So that's why we recommend foundation goes down to 0.9 meters below the ground level. This way, if any frost penetrates into the ground, in other words, there's always moisture in the ground. If it freezes, it expands, and if the foundation is too shallow, you haven't gone down deep enough, it can burst the foundation underneath the structure. Number 2 there, another reason why we dig down that deep is for seasonal and groundwater level changes. So these can change throughout the year. And of course, more moisture means expansion, contraction, expansion of the ground, less moisture, contraction of the ground. Expansion and contraction of the ground in areas of up to 0.9 meters below ground level. So again, down below 0.9 meters, water table usually stays fairly stable there, but up on shallower down than that, during the winter, obviously the water table is going to rise up. During the summer, it's going to drop down. So it would be important, like if you put in a foundation and you went down too shallow, and it was maybe during the winter time or autumn time or whatever, and everything was fine, but then during the summer, if it dried out excessively, the ground could shrink and your foundation could break. Some information now just about stepped foundations. So this is if we're working on a site that is on a slope. Stepped strip foundations used on sloping sites. These are covered in Technical Guidance Documents Part A, Structure. This section's on page 20. We can see an example there in the diagram at the bottom of the screen there, bottom of the slide, of a stepped foundation. So we can see there's a few things indicated here. We have the lap of the actual step itself, indicated by the letter L. Over on the right hand side then we have T for the thickness or the depth of the foundation, and then S is the step or the height of the step. So what's recommended is that, first of all, the minimum overlay or the lap should be equal to twice the height of the step, or 300 millimeters, whichever is greater. So if we're having a step included in the foundation, the top section of the foundation has to lap over the lower section by at least 300 millimeters, or twice the height of the step, whichever is greater. Also, the step itself should not be greater than the foundation depth. So whatever thickness the foundation is, if the foundation is 300 mil or 200 mil, then the step shouldn't be any more than that. Sometimes there might be a need to put in more than one step. Step foundation continued. The step height should also coincide with the coursing of brick or block work in order to avoid cutting and reducing the stability of the wall. So when we go building our rising walls on top of the stepped foundation, we should make sure, try and work in the steps so that they match the gauge or the heights of block or brickwork. If you can remember from previous lessons, The height of the block is 215 millimeters. If you have a 10 mm bed joint underneath that, it's 225. So quite often we'd make our steps maybe 225. Or if we can use concrete bricks for building up some of the foundations. So a brick is 65 millimeters in depth, and so 65 millimeters plus a 10 millimeter bed joint would give us 75 millimeters. So we could also put in our steps in multiples of 75, so 75, 150, 225, and so on. Worksheet, question 4. State the minimum depth a foundation should be below ground level. Some information now on the size of our foundation. The minimum thickness indicated by T in the diagram in the bottom right hand corner here of a foundation should be 200 millimeters or equal to P, whichever is greatest. This is outlined in TGD Part A, page 20. So the thickness of any foundation has to be at least 200 millimeters or equal to P, which is the projection of the foundation beyond the face of the wall, whichever is the greatest. So what's the minimum thickness of any foundation? 200 millimeters. A rule of thumb that's used sometimes is that the minimum projection beyond the face of the wall on either side should be equal to T. So sometimes we go with the projection beyond the face of the wall should be equal to the thickness. However, in technical guidance documents Part A, page 21, it states that the absolute minimum projection of a concrete foundation beyond the face of the wall, either side of the face of the wall, should be 75 millimeters. So what's the minimum projection of concrete foundation beyond the face of either side of the wall? It's 75 millimeters. If there were a failure of the concrete by shear, we can see this indicated down on the diagram there by these squiggly diagonal lines. The natural angle of shear is 45 degrees, so the natural angle would not reduce the bearing of the base on the subsoil. So this is another reason why we use these rule of thumbs. So let's just have a look briefly now at foundation walls, or these rising walls that are built underneath the ground. They're usually built in concrete blocks up to DPC damp proof course level. And DPC level we can see indicated on the diagram on the right hand side there. The DPC level has to be a minimum of 150 millimeters above the ground level. So when we're bringing up this rising wall out of the ground, it's usually a minimum of 150 millimeters up above the ground level. They are at least the same thickness as the wall that's going to be supported up above the ground level. So sometimes they're thicker depending on the actual size and type of wall, but they have to be at least the same thickness as the wall it's going to support up above. And they're usually solid all the way up, unless we're going to be building a cavity wall construction where we have an outer leaf, an inner leaf, and then a gap of 100 or 150 mil in between them. In this case, if using a cavity wall construction, the cavity begins at least 225 millimeters below the DPC level. This is in case any debris falls into the cavity when we're building it, or also if any moisture is inside the cavity, it'll flow down and out of the building underneath the damp proof course level. Okay, worksheet question 5. State the minimum thickness of a foundation and also its minimum projection beyond the face of the wall as stated in the technical guidance documents, Part A. Summary. In this lesson you covered 1. The function of the base of a building, or the foundation, which is to transmit all loads from the building to the ground. That includes dead, imposed and wind loads. Number 2, we looked at the 5 steps for setting out a foundation. So profiles are set up to support the lines, timber profiles. Number 2 there, foundation trench is marked out square. Number 3, the trench is excavated either by hand or machine, and the important thing there is that the sides of the trench are plumb, perfectly vertical, the bottom of it is perfectly level, and the corners are square. Number 4, the trench is pegged out using steel bars levelled on top, and these are used as a guide for the depth and the level of the finished concrete foundation. Number 5, a timber screed spans from peg to peg and is used for levelling the poured concrete by tamping it up and down and also sliding it back and forth, making sure that the concrete finishes level with the top of the pegs. Number 3, the bearing capacity of the ground, which is expressed as newtons, is identified through site investigation or surveys. This directly dictates the depth, width and type of foundation used, as good load-bearing ground is required in order to support any building. Number 4, foundations for dwellings should be a minimum of 0.9 meters below ground level. Number 5, minimum thickness of a foundation should be 200 millimeters, as set out in TGD Part A, with a minimum projection of 75 millimeters from the face of both sides of the wall.